addition to just thinking of them as expressions, we can think of polynomials as describing functions. So a polynomial function is just a function whose expression is a polynomial. And notice that this does not form a family of functions, right? This is not some main function composed with linear stuff. So polynomials are a more diverse bunch of functions than, say, the absolute value functions or the linear functions were. For the moment, we're just going to observe that we can have a polynomial function. And notice that we can evaluate this the way that we do any function. So if f of x is the polynomial function 2x to the third minus 5x squared plus 4x plus 7, to take f of 3, we'll say 2 times 3 to the third power minus 5 times 3 to the second power plus 4 times 3 to the first power plus 7. And now, according to order of operations, we need to work out the exponents first. And of course, you can use a calculator for this arithmetic. We'll have 2 times 27 minus 5 times 9 plus 4 times 3 plus 7. Next, we'll work out the multiplication within each term. So we'll have 54 minus 45 plus 12 plus 7. And finally, we'll work out all of the addition and subtraction. So 54 minus 45 is 9, plus 12 is 21, plus 7 is 28. That's great. You can also just take that whole thing and throw it into your calculator all at once. Just punching in 2 times 3 to the third power minus 5 times 3 squared plus 4 times 3 plus 7. And that gives us the 28 in one step. Totally fine to just throw this all into your calculator all at once, if that is, you're just trying to evaluate the function. In this example, I'm going to go through it step by step because I'm trying to illustrate something else as well. When we take f of 0, right, that'll be 2 times 0 to the third power minus 5 times 0 squared plus 4 times 0 plus 7. And notice that in each of these original terms, we're going to multiply by 0. The only term that remains is the one that didn't have an x in it, the one where we did not multiply by 0. The whole thing comes out to 7. Last one. We have 2 times negative 2 to the third power minus 5 times negative 2 squared plus 4 times negative 2 plus 7. So negative 2 to the third power is negative 8. So 2 times negative 8 minus 5 times negative 2 to the second power. Remember, that's negative 2 times another negative 2 is positive 4. So 5 times 4 plus 4 times negative 2 plus 7. Next, we'll multiply within each term. Negative 16 minus 5 times 4 is 20, minus 4 times 2 is 8, plus 7. And that'll work out to negative 16 minus 20 is negative 36, minus 8 is negative 44, plus 7 is negative 37. And part of the reason we want to think about plugging into a polynomial function is that this gives some insight into the order of operations. In expressions with more than one operation, the order in which we evaluate them is exponents first, then multiplication and division, which is multiplication in disguise, and finally addition and subtraction, which is addition in disguise. If we want to violate this order, we need to use grouping symbols like parentheses. And the reason that we choose this order is to make polynomials specifically work in this nice way. When we evaluated f of -2, first, we found the relevant powers of -2. Then, we multiplied each power by its coefficient. And finally, we added up all the terms. And this explains a weird thing that happens in the order of operations. This is why exponents have to come before negative signs in the order of operations. We want the expression -x squared to mean square the number x, and then make it negative. If it's going to mean that for x, it has to mean that for 2. So we know 2 squared, that's 2 times 2 is 4. -2 squared, written like this, that means take the opposite of 2 times 2. That's -4. If we want to actually square the number -2, we have to put that number in parentheses. So -2 in parentheses squared means -2 times -2 is +4. And the reason for that peculiarity with negative signs and exponents is because we want -x squared to mean what it looks like it ought to mean.